Hi everyone, in this video I'm going to introduce this definition command. It's very useful. So here's an example. I'm going to use a very simple task that you can do without this definition command. Two numbers are given and we're going to calculate the product if it is a positive, and we're going to return a plus b, the sum. If the product is negative, then we're going to return this value. And of course you do that because you will perform this computation with given two numbers a lot and then you use it. But even though you don't use this a lot, breaking each little task down to separate independent command like this, it is really a good idea to do a more complicated task. Whenever you have to fix it, whenever there is an error, this is the best way to go about it. So I really recommend to get used to this, using this definition command, and use it everywhere when you do this programming with Sage. So here I've typed those commands. I actually gave some sample value, a being equals 2 and b being 3. And if the product is greater than or equal to 0, and I stored that result in that output. Otherwise, which is the case, is this one. If this is not true, obviously the product must be less than 0. So I don't have to specify another condition, just the otherwise, which is else here, and output will be this different value. So once you went through that and you display the value, what that output is. So that's basically that task is written down there. So usually I always do this one first before I use definitions. With this input value, I run through the script I have and see if this is working. So when I did that, it's both a positive, so we have a sum here, and you have to experiment at changing this number and see if this is working properly. Now once you this little script you have wrote here is working, and then you can make this definition command so that you don't have to repeat this over and over again. So this is stored in some sort of custom defined function, and then you can just use that. You can just call that function. So here's how it starts. So we're going to put everything under, we're going to call that one my function. So you give these two numbers and it'll repeat this operation whenever you give this to number and call this function. So it's a definition of the function named this and with these two input and colon. So I copy them down here. Let me emphasize the importance of indentation. In the Sage, indentation means the important thing, and everything is happened under this definition, and it has to be indented. Everything that is happening under if command, it has to be indented like this. So after you determine the value of, calculate the value of output, instead of just putting an output there in the definition, you have to use the command return. So you return the value, and then this whole thing will represent whatever the value you have it over there. So we're going to run this one first. Then you usually get this no output. So now Sage knows this my underscore function, so you can just use that. So I just randomly tried this two number 34 and negative square root 2 in decimal numbers. So because the product is less than 0, they probably went through that calculation. So this is how you custom define a routine, and you can use it conveniently like this. So this is another example of using the definition command in a slightly more complicated task that we're going to go through. It's computing the greatest common divisors. So we're given two positive integers, a and b, and tasks are the following. This is implementing the very idea of computing the GCD. First, you look at the first number and get a list of the divisor. That's task 1. That's probably how you think about it in the first place. And then going through that list L, we're going to select those that divides B. And not only selecting, we'll put them in some list called M. So we select those divide B. And because this list up, because of the nature, the way we generated this L, this is in increasing order, so the last entry must be the largest one, and that's the greatest divisor. So I divide that idea into 3 groups. So we're going to use this definition command to do this task and to do that task and to do that task. And it is possible that uses very local information. All we need is a list and a given number. Doesn't matter where, in what context we're doing it. And to finish that task, all you need is a list of numbers and another number to do that. And it has the same property there. Whenever that's possible, then this is going to be useful. Even though sometimes the local task has a lot of information, you can put all those information into input area and then just do an independent task. So let me look at the task 1. So task 1 is getting a list of divisors. The commands we have in the Sage is pretty simple, so you have to think about what other task goes into that task 1. So I wrote it down, getting a list of the divisor and a given number. If we have 2 numbers given, then how are we going to determine whether S divides T? S and T has its random number. So that's another task that we have to go through. So first write down the task in this, analyzing in this way, and try to build each task correctly and define them with some name. So we'll see. So first thing we're going to do is, given 2 numbers, determine whether they divide each other. So here's a command I wrote. We're given 2 number, A and B are just a random 2 number. So A and B are given, and we're going to decide whether A divides B. The idea is looking at the integer part. I'm not going to go into the discussion of the mathematics here, but I'm claiming that integer part of this one being exactly the same as the quotient itself, that means it divides evenly. So if it divides, we're going to indicate it with 1 in that value dv. If it doesn't divide, then it's going to be 0. So remember, 1 is yes and 0 is no. So this divisible 3, 5 will be representing 0 value because 3 does not divide 5. So next time when you have to decide, you just simply run this command, divisible and 2 numbers, whatever you want, whatever they are. That's that task right there. We have that one. And let's look at the second one. We're going to get a list of divisor when a number is given. So only input here is a positive integer. So here's the task I wrote. I named it divisor list. 1 number is given. So this is going to be a collection of divisors. So I create an empty list. Whenever we discover as we go through 1 through A, so here's 1 through A, and we're going to collect them in here. So K is going through 1 through A, and every time we test if K is dividing A. And if it is so, it's going to be the value 1. If that's the case, we're going to append that value to our list, and after all this went through, and it's going to return that list. That's exactly list of the divisors. So we accomplished that task. If you give that 1 number, that command will get a list of the divisors. The second task is here. A list is given, and then the second number is given. We have to come up with a sublist of that under that criteria. So I named it here select a divisor. One of the input is a list, and the other one is a number. Again, I'm creating an empty list, and we're gonna collect the numbers inside that list right there. So I'm going through all the numbers in this list. It's very convenient command in the Sage. You don't have to worry about labels and indices, just to put down the list, and K will go through that list. Every time we just test, I don't know, for some reason that part was missing, so I typed in if K divides B, so that's the value must be 1, then we're collecting in the temp list. And after we went through all that, and we're going to return that list. That will be the entries in that list L that divides B. So that part was done. Next part is given a list, and we're going to produce the last entry. And this is a very simple task, and My suggestion is that it doesn't matter how simple is that task, and if you wrote it down, you better just write it as a def, and then you will not regret. That is really a good idea. So here's a simple task. Here's a list is given, and we calculate the length of the list, and the correct index for the last entry is nn-1. So you return that value. So we got that last entry part. Now what we have to do is that created another definition that is doing all these tasks at once, calling all the things that we have defined. So here it is. First, we're given two numbers, a and b, both are positive, and by doing this divisor list A, we get all the divisors. And using that divisors, and we select the entries in this temporary list that divides B. And then we don't need that temporary list anymore, so throw away that old list and then kind of renew that list with the selected entries. Now these are all the common divisors, and in here the greatest one is the last entry, so just to return the last entry. Now if you execute the whole thing, now the computer will know all the, Sage will know all these little definitions that you have created before. So if you just put those two numbers, and it's going to go through the brute force search, what is the, we're going to find what is the greatest common divisor of these two numbers. So again, I highly suggest that when you do something, always use this all the definition and write down the little task of your things that you were doing, and try to call all the customized function. It's easier for the reader to understand, easier for you to fix the mistake, easier for you to develop a new program out of the given one, and it's the right thing to do. Thanks.